In the last video, we talked about the concept of parallel lines. We said that it can be understood in three different ways. If you have not seen the previous video, you can check the link in the description. In this video, we will use one such notion of parallel lines, one such way of viewing parallel lines, and use that to solve a problem from Math Olympiad geometry. So I will briefly recall what that way of seeing parallel lines is. It's very simple. Two lines are said to be parallel if you are walking on either of them, you are actually traveling in the same direction. So there is a notion of direction that is ingrained in this particular way of seeing parallel lines. Now let's talk about the problem that we can solve by this way of seeing parallelism. It's very simple, but first I have to say what is a orthocenter. In fact, I will draw the main diagram of this problem. To do that, let me first draw a circle. So you can also draw it by pausing the video, and then draw a cyclic quadrilateral like this: A, B, C, D. A cyclic quadrilateral, and then join BD and AC. Join BD and AC on this particular quadrilateral. We want to draw the orthocenters of triangle BCD and the orthocenter of triangle ADC. Let me tell you what orthocenter is. It's very simple. You take a vertex of a triangle, you drop a perpendicular to the opposite side. This is known as the altitudes. It's a theorem in geometry that all the altitudes of a given triangle pass through a single point, and that point is known as the orthocenter of the triangle. So in this particular case, let me draw the orthocenter. From the point B, I will drop a perpendicular on DC. So notice that the feet of the perpendicular is not on DC, it is on DC produced. That's fine, that's alright. So this point is perpendicular. At this point the altitude is meeting DC. Similarly, from the point D, if I drop a perpendicular, the same thing will happen. This perpendicular is on BC, but it will not directly hit BC, it will hit BC produced. So maybe I can produce BC like this, and this is not also 90 degrees. So we have the two altitudes, and in this particular case it's kind of peculiar that the two altitudes are hitting in the extended sides. Now if I extend the altitudes further, they will meet at the orthocenter of triangle BCD, which is the point H1. Now similarly, I can draw the orthocenter of triangle ADC. I draw a perpendicular like this, I drop another perpendicular like this. These two are 90 degrees, and this point of intersection is H1, H2 suppose. So H2 is the orthocenter of triangle ADC. Now we want to show that BH1 is parallel to AH2. We will use that way of seeing parallel lines. Notice that BH1 is perpendicular to CD by definition, and AH2 is also perpendicular to CD. Though H2 is not on CD, the direction in which you travel, I mean if you extended it, of course it will hit perpendicularly CD. So both of AH2 and BH1 are moving perpendicular to CD. Therefore, they are moving in the same direction, hence they are parallel to each other. It's a very simple way of seeing parallel lines.